Let's take a look at the topics on Regents Review letter N. The expression 3x squared plus 4x minus 8 when added to 2 times the quantity 11 minus 5x is equivalent to which expression? So we're going to distribute here. So after we distribute, we're going to combine the like terms of the x's and the like terms of the constants, leaving us with 3x squared minus 6x plus 14. Question number 10 asks us to solve this inequality, first by distributing -3, and then by using our properties of equalities to move terms to either side. I'm going to move the 2x to the left, and the 18 to the right. And don't forget, when you divide an inequality by a negative value, that you reverse the order of the symbol. So we're going to get a less than sign with our 4. This question has to do with exponential growth or decay. And I see here an exponential function. And this 1 represents having 100% of your initial value. And this number here represents it as an increase of 5%. That's what 0.05 represents, an increase of 5%. So I already know it's an increase, so these two are eliminated. And I realize that this is the same digits, but you don't have the percent sign next to the number, so this one cannot be the same value. It's an increase of 5%. For this one here, the range would be something I could find in a table, right, for this function x squared plus 2x minus 5, or I can find it in a graph once I graph this quadratic. So that's what I'm going to do first. I'm going to take a look at what that graph would look like by turning my calculator on and using the y equals button here. I'm going to type in x squared plus 2x minus 5. And when I look at that graph, I notice that it has a minimum value here at -1, -2, -3, -4, -5, which makes sense because the constant here is -5. That's my y-intercept. So it looks like the y-intercept is -5, but the minimum value is a little bit to the left. So I need to find what that value is. So I'm going to press second trace. I'm going to calculate that minimum, number 3, and first I need the cursor on the left side, and then I need the cursor on the right side, and now I have that zone, so I can press enter, and it's -1, -6. So the point is -1, -6, right, when I'm graphing it, -1, -6. So that means the range is everything that is higher than -6, or greater than or equal to -6. For question 18, it asks which statement is true. So these are inputs. F of 1 means if you put a 1 here and you put a 1 here, would it be equal to the answer of if you put a -1 here and a -1 there? So instead of computing all of the math myself, I'm going to turn my calculator on. I'm going to go back to my y equals button, remove the last function, and put in the new function, which is plus 3x. I'm going to delete everything else. Here we go. And I'm just going to look at the table. So let's see. An input of +1, which is right here, has an output of 4. So this would be 4 for this one. And an input of -1 has an output of -2. So this is not true. Now an input of +2 has an output of 10, and an input of -2 has an output of -2, right? I see that in my table over here, and again, this is another statement that is not true. So an input of 1 is 4, an input of 2 is 10, also not true, An input of -1 is -2, and an input of -2 also has an output of -2. So I use my table to compare these values instead of plugging in each number myself. All right, questions 24, and then the final one over here, number 8. So let's take a look at 24. They're asking which one is a correct way to figure out this conversion from liters to euros. So remember, in order to convert, you have to have a cancellation of a unit in the numerator with a unit in the denominator. So this one leaves us with dollars per gallon. This one over here doesn't have enough crossouts. This one over here doesn't have enough crossouts. And this one down here doesn't have any crossouts. So that means that this one is the conversion for dollars per gallon. All right, number 8, which statement is not always true? The sum of two rational numbers is rational. The product of two irrational numbers is rational. The sum of a rational number and an irrational number is irrational, or the product of a non-zero rational number and an irrational number is irrational. If you don't know the rules about which sets of numbers are closed under addition, subtraction, etc., then you just have to find a counterexample, right? Which statement is not always true? So you'd have to come up with an example where when you're adding two rational numbers, it wouldn't be rational. And that is true. Rational numbers are closed under addition. So anytime you add two rationals, you can only ever get a rational. So let's try the second one. The product of two irrational numbers. So let's say I've got the square root of 2 times the square root of 2. Well, that would be the square root of 4, and that is a perfect square. So it is true, but the question is it always true? Let's try a different example. How about the square root of 2 times the square root of 3? Well, that would make the square root of 6, which is an irrational number. So this is not always true. Back to our rational and irrational questions, they want you to classify what the answer for this one is. So I know that the square root of 144 is a perfect square, and if I didn't know that, I could simply turn my calculator on and I can evaluate it. The square root of 144 is 12. I also know that the square root of 169 is 13, so I can check that here, and I see that it's true. So I could replace this with a 12, and I can replace that with a 13. I can, in fact, add these fractions together, either myself by rewriting this, or renaming this as a 12th, right? So this would be 12, and this would be for 52. So 52 plus 2 is 54 twelfths. And this is, in fact, rational. And I know that because it's a ratio. So I can explain my reasoning by showing this math, justifying this. And I could say it is rational. That's the first thing I need to answer. Because the sum of 2 twelfths, or 2 over 140, square root of 144, and the square root of 169 over 3, the sum is a rational number. Another thing that you could say here is the sum can be written as a, here's the money answer, ratio of two integers. Right? This is an integer, that's an integer, and they are a ratio of two integers, as shown in the work above. It's rational because the sum can be written as a ratio of two integers. All right, next question. An application developer released a new app to be downloaded. The table below gives the number of downloads for the first 4 weeks. Write an exponential equation that models this data. So if I wanted to write an exponential equation, I would have to know the value of 0, right? That's the initial value for an exponential function that looks like this. So I could either work my table backwards, figure out this pattern, right? Or I could use my regression equation, regression on my calculator here. So here's what I'm going to do. I'm going to go to Stat Edit, and I'm going to enter 1, 2, 3, 4 into my 1 button. 1, 2, 3, 4 into my list 1. Into my list 2, I'll type 120, 180, 270, and 405. Once I do that, I go back to Stat, and I calculate, and this time I'm going to do exponential regression, which is 0. It's asking if this is where my data is. Press Enter 5 times, and there we have it. So the initial value is 80, and the rate of growth is 1.5. So an exponential function would be 80 and 1.5 to the x value. If you're curious where the calculator got that from, when you want to find the rate of growth or change, you choose any two values, and you divide the second by the first, right? The second by the first. So 405 divided by 270. So if I did that on my calculator here, using this button, I can do 405 divided by 270, and there's the number. I'll use this model to predict how many downloads the developer would expect in the 26th week. So that means that the time would be 26, or that would be my exponent. Let's go back to our calculator. Let's type that in. 80 parentheses 1.5 parentheses power of 26. So let's see, 3,030,140. 3,030,140. Point, what was it? 195.195. So it asked me to round to the nearest download. So that's not going to round me up. So that's it. 3,030,140. Next question. Would it be reasonable to use this model to predict the number of downloads past 1 year? So past 1 year, that would be any number that's higher than 52. So what if I change this to 2 years, like 104? Would that be reasonable? Whoa, look at that. That E represents a scientific notation, or the fact that this number has 20 more digits after it before it actually has a decimal point. So we'd have like a 1, a 6, 4, 5, 6, 4, 6, 5, 7, 2, 7, 6, 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would need 11 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we'd have a decimal point. And this would be our amount of people. And so we can say, no, this would not be reasonable. There aren't even that many people on the planet because there are not that many people to download the app. The number is just too high. All right. This question was on another worksheet here. This one is a good fit. This one is a poor fit. Graph A has no pattern. Graph B has a pattern. Graph A is a better fit. That concludes worksheet N.